dogs, chickens. Looking for a good cow CD. No, I have a Christmas chicks CD. I didn't expect us to have it. No. See, that's the thing. I'm not sure cows can hear you too. Haven't found one yet. All right, 7.6 is about natural logarithms, and we've talked about these before. On your calculator, you're going to see this. The big capital L, capital N button. That's the one that has the second feature, which is the E, the X button on it. It's not supposed to be written that way. It's supposed to be written as LN, but in reality, it should be a cursive L and a cursive N. But when they put it on the calculator and they handed it out to people to try out the calculator, people were saying, what's up with that N button? So they made it capital L, capital N, so everybody would remember, oh, that's right, it's natural logarithm. Where does that name come from? Well, Euler's number, which that's how I always refer to it as Euler's number, way, way, way back in history was called the natural base. And that's why it's called the natural logarithm, is to undo Euler's number, which is the natural base. So what we're going to do today is we're going to talk about evaluating and simplifying natural logarithmic expressions. And truly, we're not learning anything new today. The one key to what we're going to do is to constantly remember that ln has a base of 2. That's what we've been doing to solve logarithms with the snapshot. So it's not new, but it's going to feel very different because of that obnoxious little E piece. We're going to have this feeling like, can this be working the same way? Solve equations using natural logs. So we'll get both of these things in there today. Now, we started here. We have talked about how exponents, unknown exponents with a nice base, are growth. I mean, that's just what they are, growth and decay. So right here, we see the graph of y equals e to the x, which it's been a while since we saw e. Let's all get e on our calculator so we remember what that number is. Anybody memorize it? Nobody's got 2.718 in their noggin yet? And e is so rarely used, it's not something you really need to memorize. There we go. So that is growth if that's your base, and it is in this case for y equals e to the x. And then if we reflect in the line y equals x, which is what you're supposed to do for inverses, that's the whole reason we switch the x and the y, you would get this, which is, of course, y equals the natural log of x. And that's because the natural log of x is the logarithm base e of x. That's the reason that works. Now, super cool relationship. Going to be some in your homework that look this way. I want you to think about what that says. What does that say? 5. That's what it says. It says 5. They're inverses of each other. ln is logarithm base e. Now, see how it's something we already know, but it's different because of that whole ln thing. You know, you have to stop and think of it. It's logarithm base e. Oh, wait, this says 5. Well, that's what they do.
How neat is that?
So it is. It is the coolest inverse relationship that we have. Like I've talked about before, if you want to get rid of multiplying, you have to do something. You have to divide. But for inverses with our unknown powers and logarithms, it's just like they mesh so perfectly, they just make each other disappear. It's just what they do, which is very cool. So up here it says a function f is bounded above, we talk about this a lot, bounded above if there is some number b that f of x will never get higher than. So if our graph stops before it crosses some horizontal line, then it's bounded above. Pretty obviously, this arrow is telling us that this red graph, y equals e to the x, it's not bounded. It's going to go up forever. But does this continue up forever? Or is there like a cutoff somewhere as you go to the right forever, where it just kind of evens out and doesn't continue on in the y direction? Well, to know that, it's actually easier to look at So here's what we do. We think about our wonderful little red graph up there, and we find its domain and its range. And here's why. The logarithms, because they are the inverse of these unknown powers that we're talking about, the domain and range are going to flip-flop. So if we can find the domain and range of this, we can just flip them and discuss what's going to happen with natural logarithm. Well, you can put whatever power you want up there for e of x. So whatever we have for x is all reals. Pick whatever you want. But our range, we had to talk about this when we were in our book before. This is never going to cross the x-axis. It's going to go up forever, but it's never crossing the x-axis. So it has to be y is greater than 0. So when we get to our blue graph, those two things swap. Remember, the first step for writing inverses is switch the x and the y. That's all for y. So all the x's become the y's. So if we want domain, that comes from the y's. So that's going to be x is greater than 0. But our range, which is what they were asking us about, is it ever going to stop going up? That's the domain of this one, and that's all reals. So neither one of those graphs is bounded above. Neither one. And I hope, as thinking people, you are saying, are we ever going to encounter a graph that is bounded above? Absolutely. We are going to study sine and cosine graphs in pre-calculus. And those are not only bounded above, but also bounded below. And that's called bounded. So, take a little piece of it today and just talk a little bit about that. Now, the reason I left that in there is not because it's such a great fit with what we're talking about today, but it's because it's where you're going about things. Pretty much, you're not going to have anything in your assignment that asks you about bounded. It's just something to get you thinking about as you're going through your math. So the function y equals e to the x has an inverse. We absolutely know that. And that is the natural logarithmic function. And somebody in second hard asked, so why isn't it NL? I mean, if it's the natural logarithm, why isn't it NL instead of LN? I don't know. I could try and look that up. I would guess it has something to do with the Greek language when they came up with this. It switches things around. But that would just be logically thinking through it on my end. So this one says, remember, y equals ln of x is really logarithm base e of x. So we need to get rid of it with a snapshot. That's what we're going to do. Essential understanding is the functions y equals e to the x and y equals ln of x. Those are definitely inverse functions. And just as before, that means if we have one, we undo it by doing another. That's just what we do. So away we go. Got a little graph down here to peek at. And it just shows us, hey, there's that y equals e to the x that we had in the getting ready. And here's that y equals natural log of x. And those are definitely inverses. And we could make that happen. I mean, if we start with y equals e to the x, we know the rules are switch the x and the y. And then we just have to think backwards. Okay, so what did that say as a logarithm? If this is what they got after they snail shelled, what did it look like? Well, it would have had to be base e, because we go e to the y equals x. And then we know the shorthand for logarithm base e is just ln. We could do that. On the test, you're going to unsnail shell some stuff when you get to the test on this stuff next week from tomorrow. We'll do some unsnail shelling. So they're inverses, and we could find them. They wouldn't have to tell us that they're inverses of each other. So on the next page, it's get to it. Let's do this. What is 2 natural log of 15 minus natural log of 75? Hey, wait a second. Our objective was evaluate and simplify natural logarithmic expressions and solve equations using natural logarithms. Yeah, this is part one. I mean, this is the first part of the objective. We have to simplify it first because, like I was talking about during the homework, we need one logarithm, one thing equals one thing, and then it gets snail shell. This is not one thing. So think about what we already know about logarithms. What would you do first? Put the 2 back up. Yeah, exactly. It's the first thing you encounter that you go, wait a minute, that's not supposed to be there. So that should be the natural log of 15 squared. Hey, we have that one memorized, don't we? 15 squared. 325. All right. And then we just have subtraction to get rid of. So we get this into one logarithm. So what's subtraction do? Division. What is it? It's 3. So we really simplified that one. From 2 natural log of 15 minus natural log of 75 to natural log of 3. Now, it does have a number, but notice I didn't say, okay, let's stop and figure out if this is something nice. E to the something is rarely something nice. So we could, just for the sake of an argument, say e to the something is 3. No, it's not nice. It's nasty. So you do think about it for a second, but you don't search for too long. Alrighty, I need you to help me with these. We have natural log of 7 plus 2 natural log of 5. What you thinking about first? Put the 2 back up, exactly. And I'm just going to write 25. I'm not even, well, I'm probably better not do that for people that are looking at the notes. Let me do this instead. Go up there. Addition. If you have 7 quarters, what do you have? E to the something 175, going to be something nice? Like I said, don't spend too long thinking about it. If it doesn't pop into your head right away, then it's not something nice. Alrighty. B says 3 natural log of x minus 2 natural log of 2x. Back up. Wait a minute. What is that 2 in front? Oh. I mean, there's no parentheses there. Are they grouped together? They are naturally grouped together because they're being multiplied. So what we have to do with this one is be very careful and say, hey, they were grouped together. There was multiplication taking place there. They are together. So both of those, the 2 and the x, need that square. So 2x, the quantity squared. What's that? 4x squared. Exactly. Both of them get the 2. Remember, we can distribute if there's pure multiplication or pure division. So 4x squared. Whew. Almost done. Subtraction. Division. Maybe we can simplify that. Take an x squared out of the top and the bottom. Now that one we don't have to check to see if it's something nice. It's got a variable in it. That's done. Give C a try on your own. Let's see what you get. Really good. I would ask that you think about what you have behind the LN and whether or not you should change the order so that it looks and feels like the algebra that you've done before. Remember, algebra is about thinking about what you've already done and how you can apply that Alrighty, so it looks like nobody had a whole lot of trouble doing this. And then realizing that this was going to be. But that's just awkward, right? Yeah, that's awkward. We know that we should put the coefficient in front and that we don't really need the parentheses because in algebra when things sit right next to each other, it is multiplication. So we definitely put the coefficient in front, put 5 in front and go from there. So it looks like you're doing fabulous on that, which means we got to learn something else, right? Keep going on our objective. We can use inverse relationships between the functions y equals ln of x and y equals e to the x to solve. That's what we need this for. Certain logarithmic and exponential equations. Remember, way back when, we talked about Carl Friedrich Gauss and how he wrote the fundamental theorem of algebra and said, if there's an x in it, by golly, there's an answer. And mathematicians went nuts trying to find the answers to all kinds of equations. And we just tip of the iceberg, you know. Obviously in Algebra 2, a lot bigger tip of the iceberg that we cover than in exponential. But generally, that's why there's a college algebra after this and a pre-calculus. And lots more fields of math that open up after that because there's still a lot to learn. So this says, what are the solutions of this bugger? So I think Cederholm said 1 natural log of one thing equals one thing, and then you can snail shell. Is that ready to snail shell? It is. It's ready to go. Down to the base. Okay. It is. It's base E. So what you might want to do as you get used to ln is write it as logarithm base E. That way you can see that snail shelling as you go through it. So e to the 4th equals x minus 3, the quantity squared. Okay, so here's what I have to think. Do I really want to write out x minus 3 times x minus 3, do the FOIL, and get x squared minus 6x plus 9, and have this be huge, and work my way back? So I start thinking, is there another way to get rid of this plot, this 2 up here? How can we get rid of that? We could take the square root. Now when we do that, we have to be careful because remember we're going to have that little plus or minus piece. So plus or minus, wait a minute, plus the square root of e to the 4th. It is e squared. Remember, square root is the same thing as 1/2. So 4 times 1/2 would be e squared. Or you can think, I have to put e to the something in these 2 spots and multiply it together and get e to the 4th. It has to be e squared. It has to be. Now we're almost done, because this is going to be a calculator problem. Well, what would we do to get x? Well, just add 3. That's it. And we want those 4 decimal places. So 3 plus e squared, 10.3891. Ooh, that got smooshed. And second enter and just cheat and change that to subtraction. Negative 4.3891. Wait a minute. That's a negative. Those have caused problems in the past. Let's see if a negative answer is going to cause trouble in this. Should we scribble it out? Is it going to work? Negative minus a negative gives you a negative. But look at that. It's going to make it positive. So both of those answers are okay. Since we have that little squared up there, they're both fine. Doesn't matter if we have positive or negative. So it's not a guarantee just because it's negative that it's not going to work. You have to go back up and see, well, what are they doing with it? What's the math that's going to be applied as you go through there? Well, that's kind of a monster. see what else. Ooh, this looks like a little baby problem comparatively. All right, natural log of x equals 2. What do we want to do? Right away?
Oh, well, you got it.
You can't. You know, if here's the problem. I always say this. In your notes, it wouldn't hurt to write logarithm base e of x equals 2, because sometimes you go back and you look at your notes and you go, what did I do there? How did I get from that step? But if you're able to look at it right away and you know, hey, that's logarithm base e, then just snail shell it immediately. Look at that. That was a quick one. Second, ln 7.3891. All right, let's look at B. Well, that looks familiar. Plots. Snail shell. It's ready to go. One log, one thing equals one thing. Yeah, this looks real familiar. Ooh. What do you have to remember when you do that little square root thing? Plus or minus, and then what's the square root of e to the fourth?
E squared.
Epsilonte, then what? Subtract 5. This one's got an extra step for us, doesn't it? You still have one to go. Divide by 3. These answers will be obnoxious. If it said give an exact answer, we would stop right there, but it never does in this book. This book always says, hey, let's just get this to the 10,000th position. So let's see, I'm going to need -5 plus e squared divided by 3. So 0.7964. And then I'm going to cheat and go back and change this to subtraction because I'm lazy and I don't want to punch it in twice. Second enter pulls up the last thing that you punched in so that you can go back and change it. Second and enter.
Also, and you guys don't know the ins and outs of the calculator yet. Yeah. So then you can just change it.
Yeah, just change one thing. Punch it all in at one time. Be very careful with the parentheses. Second enter, go back and just change one thing.
Yeah. Oh, so then you just like move the right arrows over the positive and then click the minus positive.
Hey, that negative might be a no-go, right? Go back. Look at the original. Tell me. Will that negative work on this one? Why is it working? It's squared. We got a power of 2. Both of them are golden. Yeah, I don't know what you do on the Inspire. Can you recall stuff? Did you show how to recall? Okay, good. I've got to be able to do that on the Inspire. The thing practically does your laundry for you. All right, C. This looks difficult. What's the issue? Gotta combine them. How do we combine them? Multiplication. No, it's not a big deal. What do we do next?
Snail shell.
We do. E squared equals 6x. How do we get our answer?
Divide by 6.
What we do? I better put approximately x here. E squared divided by 6.
It's got like no.
Right, too big. 1.2315. this one?
I don't know.
Exponential equations. Oh, that looks hard. But it's not. Why? Because we have excellent algebraic instincts in here. This is not hard. Yeah, you subtract 2. You know, you use your algebra instincts. Normally, we would subtract 2. I'm going to subtract 2.
How would you divide by 4?
You do, because you have to expose the base. The base has to be all by its lonesome.
Yes.
Isolate. Fancy word, isolate.
3.5. 7 over 2.
Log base e on both sides.
Snail.
Bam.
Pretty smart. What is that?
Inverses. Divide by 2.
That's pretty neat how you do
It is.
that.
We're following the rules. Yeah. So natural log of 7 halves. Divide that enormous decimal by 2. 0.6264. Not bad. Now remember, if I keep my calculator with the answer in it and I check this, it's going to work out perfect. If I put this back into the original, it's just going to be a teensy bit off. You know, it's not going to be quite there because we did have to round it. Granted, we rounded to 10 thousandths, which is a teeny little bit of error there, but it's still going to be a little bit off, a little bit. All right. Oh goodness, these look difficult.
Question mark stuff.
Right away? Yeah, the base is exposed. Nothing else to move over because this is part of the power. Add 2. So do you suppose we could punch in natural log of 14 and get the right answer? No. This is a logarithm number. This is an integer. Cannot combine those two. Need to make sure you finish off those parentheses or this is not going to come out nice. Well, not that it's going to come out beautiful in the first place, but. 4.4849. B. Right away? Divide by 2. Expose that base. It's exposed. It's naked. It's a naked base. Got it? 4 decimal places? Negative 2.3026.
So almost like this, or like the one on the top.
Oh.
No, I mean like the homework problems and like got it 3 or in the problem 2 at the top.
Hold on.
Yeah.
You'll have some
Okay.
that deal with things that way.
I meant like the majority.
It's about the same for
half
each
and
one.
half.
It's about the same for each one, yeah.
Yeah.
Alrighty. Well, this must be more complicated.
The last one. No.
Oh, what do we do?
It's a track.
We do. Then Logarithm.
Natural logarithm.
Then
Divide by 3.
5 by 3. Approximately, what is it, 0.7675? Because I know lots of you already did this.
Yes.
Is that right?
Hang on.
0.7675.
Yeah.
I better make sure I.
43210. How you feeling about our two lovely objectives? Simplifying them, solving today. Good. Got some people with total confidence. I got this. I'm a 4. Lots of people with 3s.
I'm a 4.
And that's not you. And that's not you.
I'm a 4
That
on
one's you.
my ability today. That's section 7-6 day 1. I'm a 4.
There we go. So, if you're doing the homework and you're thinking, see here, well, we didn't have all the examples like we did in class in the homework. I'm saving some for tomorrow. Because tomorrow we're going to do one problem about rocket science. Is that cool or what? We're going to do a rocket science problem, and we're going to take a little formative on your Chromebooks. So please make sure you bring your Chromebooks.
What's up, format?
A formative is a quiz to show me where you are at. Doesn't go in the grade book, but it shows me what you know at this point.
Is it gonna go over like everything here or just this unit?
Probably just 2 sections. Probably, I think it's 7-2 and 7. No, it's 7-3 and 7-4.
Eli,
What?
I'll give you $30 if you finish this assignment in 7 minutes.
Really?
Yeah.
Eli will find a way.
You know, using practical.